Let's look at the probability section. Here we're looking at a table representing the results on the bar exam of law school graduates. You can see that a small amount out of our total 200 graduates actually passed the bar exam. And I suppose we're trying to consider, did this review course help students pass it or not? Out of those that took the review course, 18 of them passed and a whole bunch didn't. And out of those that did not take the review course, 7 passed and even more did not pass. So it seems like it had some benefit if you took the review course. Let's read on. The question asks, if one of the surveyed graduates who passed the bar exam is chosen at random for an interview. That refers to column 1 in its entirety, 18 plus 7, because there are 25 total graduates who passed the bar exam. So that is our pool of potential candidates. They ask, what is the probability that this person chosen did not take the review course? So out of these 25, 7 of them did not take the review course. How did we get to 25? This was adding 18 plus 7. And there's your answer. Next up, we're looking at dreams recalled during 1 week. And I suppose a researcher was trying to figure out, do people remember dreams more often with early bedtimes, like in group X, or with later bedtimes, like in group Y? They tracked this for 1 week, which is a pretty small sample size, and participants either reported remembering 0 dreams, 1 to 4, or 5 or more. They say if a person is chosen at random from those who recalled at least 1 dream. Which column is that? It turns out it's multiple columns, but not all of them. If you recalled 1 to 4 dreams, well, that's at least 1. If you recalled 5 or more, that's also at least 1. You could add all of these numbers, 28 plus 57 plus 11 plus 68, but they have the totals of these columns here for you. So our pool of potential candidates can be found by adding 39 plus 125. We'll put that on the bottom of our fraction. Within this pool, what is the probability the person belonged to group Y? So, out of all the participants that dreamed at least once and recalled it, which ones belong to group Y? That is 11 and 68. We will add these two together, and this will be our numerator. When you do your addition, you'll have your probability. Next up, there's a prize. It's a contest. There are only 25 people, so it's a pretty nice contest to be a part of, and they're choosing totally at random. They have segregated the participants by age and by gender. A key part of this probability is recognizing that the winner could be either a female under age 40 or a male age 40 or older. That conjunction or means that we'll take the probabilities separately and add them. In this case, it's not going to be both events happening, the female under age 40 and a male age 40 or older. That would be ridiculous. There's only one winner. But if that was the case, we would end up multiplying the probabilities instead of adding. Either way, female under 40 can be found right here. 8 out of the total applicants of 25. And we will add this to males 40 or older, which is 2, also out of 25. So the combined probability is 10 over 25. Ice cream and topping selections. First off, of the people who chose vanilla ice cream. That tells us we're looking at the sum of column 1, 8 plus 5. Out of all these 13 people that chose vanilla ice cream, what fraction chose hot fudge as a topping? Well, 8 of them did. Our fraction is 8 over 13. Next up, we're looking at surgeons of a couple different types, general surgeons or orthopedic surgeons. Within those categories or types of surgeons, What is their major professional activity? Some surgeons teach, some focus on research. They say if one surgeon is selected at random, this could be any of the surgeons. So the very bottom right number, or our total of 607, will go on the bottom of our fraction. To go on the top, we're indicating an orthopedic surgeon whose professional activity is research. So you follow orthopedic and research, and your answer is 74. If you divide this number, it's going to be very close to one of these choices. Handedness. There might be an easier way to do this, but if we set up a ratio, we can build a system of equations, solve it, and use that to build a probability. So we know how many total left and right-handed people there are at this school, at a middle school, and we know the ratios for females and males. We can write it like this. There are 5 times as many females who are right-handed, so 5F versus F. There are 9 times as many males who are right-handed, so M versus 9M. If we wanted to turn this into a system of equations, we know that F plus M is equal to 18. Or in other words, the number of left-handed females plus the number of left-handed males is 18. For the right-handedness equation, we would add 5F plus 9M is equal to 122. We could solve this system by either using elimination or substitution. I think it's easier to use substitution, probably. So if we start with F plus M is equal to 18, and we subtract M from both sides, we get F is equal to 18 minus M. We can take this and plug it into our other equation for F, replacing it, and we get 5 times the quantity 18 minus M plus 9M is equal to 122. When we distribute the 5, we get 90 minus 5M plus 9M is equal to 122. We'll subtract 90 from both sides, and we'll combine those terms, and we end up with 4M is equal to 32. When we divide by 4, we get M is equal to 8. Let's use that to plug it back into our table. If M was equal to 8, so we'll replace M with 8, 9 times 8, which is 72, then we can figure out how many females were both left and right-handed. So out of the total 18 left-handed students, 8 were male, 10 must have been female. And if F is equal to 10, then we multiply this and we get 50. Now, what did the question actually ask us? It said, which of the following is closer to the probability that a right-handed student selected at random is female? So we're looking at all right-handed students. There are only 122 of them. And how many of them are female? 50. Our fraction becomes 50 divided by 122. This will give us either A, B, C, or D. Two more questions. Number of registered voters in the United States in 2012 in thousands. So they have it sorted by age groups and by regions of the United States. And the total voters is there in the very bottom right. There's not actually 153,000 people that voted. Remember, it's in thousands, so that's more like 153 million, in case we were feeling very depressed about voter turnout. So if a registered voter who was 18 to 44 is chosen at random, the age range 18 to 44, that encompasses both of these columns, 18 to 24 and 25 to 44. It did not specify a region, so to find the possible pool of applicants, we're going to add the totals. 14,766 plus 47,896. That'll go on the bottom of our fraction. Within this pool of possible voters, which of the following is the closest to the probability that the registered voter was from the Midwest region? Those are the numbers that represent this age group and Midwest. We add those. Goes on the top. Remember order of operations, we're going to put those parentheses in, so we will add before we divide, and we'll get one of these four answers, or something very close to it. Last one. Algebra 1, Geometry, and Algebra 2. Pretty familiar for a high school. There are two ways to approach this. First off, we can start with our total number of students, 310, and multiply this by 19%. If we do that, we'll quickly identify the number we're looking for, which turns out to be 59. Another way of doing it would be identifying the number of females taking geometry, which turns out to be 53, and dividing that by 310. The number of females taking algebra 2, which is 62, and divide that by 310. Taking the number of males who are in geometry, which is 59, and dividing it by 310, or the males taking algebra 1, 44, and dividing it by 310. This is the long way, and this is the way that Anthony did it. So nice job.